Hi ladies, this is Mrs. Blaufuss here. This is the video for October 10th and October 11th. In this video we're looking at perpendiculars, specifically perpendicular lines. So looking at this first example, if you remember, perpendicular means lines that intersect at a 90-degree angle. So in this figure it says OP is perpendicular to MN. I'm just going to outline those lines so you can see. OP is perpendicular to MN. When we have lines that are perpendicular, we mark them with that little box. Okay, so you can see that this 90-degree angle is already marked right here. And then the second set of lines says that NP is perpendicular to QS. So here's NP that is perpendicular to QS. And again, you can see right here that it's already marked perpendicular. So we're going to answer these questions as to whether they're true or false based on our diagram. It says angle PRN is acute. So let's look at PRN, P to R to N. And we're going to use the theorems that we already know. So in this case, we're going to use our linear pair theorem. So we know that MRP and PRN form line MN. Therefore, it has to add up to 180 degrees. So angle PRN here, the statement that says that that's acute, that's false because we know that PRN is 90 degrees. Okay, so this first one is false. It's 90 degrees. Okay, let's look at the second one, talking about angle 4 and angle 8. Here's angle 4, here's angle 8. The statement is that those two angles are congruent. And this is true because they're vertical angles. Let's look at the next one. It says measure of angle 5 plus the measure of angle 6 is equal to 90 degrees. Here's angle 5. Here's angle 6. Together, they do equal 90 degrees. And we already said that PRN is 90 degrees because of our linear pair theorem. So together, they are 90 degrees. True. And the linear pair theorem says that they're 90 degrees. And then the last statement is QR is perpendicular to PR. So let's look at QR is right here. Is that perpendicular to PR? If it was, this would have to be 90 degrees, which it's not. We know that it's not 90 degrees because we know that that MRP is 90 degrees. So this last statement is false. Okay, so let's look at a couple new theorems we have. The first one is the perpendicular right angles theorem. And this theorem says that if two lines are perpendicular, they form 4 right angles. Okay, so in this diagram, I have 2 lines that are perpendicular. I have 2 of the angles marked. I could mark all 4 of them. But if I know that one of these is 90 degrees, I know that all 4 of them are 90 degrees. And then the next theorem is the perpendicular lines theorem. And the perpendicular lines theorem is a little wordy. It says if a line M is in a plane and T is a point on line M, then there is exactly one line in that plane that's perpendicular to M at point T. Let's draw a diagram. So let's look at this diagram. Here's line M. It's on plane P, and T is on line M. Okay, line M is the blue line. This theorem says that there's only exactly one line that goes perpendicular to M at point T. Okay, so it has to go through point T and be perpendicular to line M. There's exactly one line that does that. Okay, let's look at this next example. This example, we're using a circle, and we're looking at an angle within the circle. Okay, so EG would be a chord, TG would be a radius, CG would be a chord, ET would be a radius, and EC would be a diameter. Okay, so let's look at this example. It says the measure of angle EGT and find the measure of angle EGT and the measure of angle TGC. Okay, so we're finding these two angles. We know that EG is perpendicular to CG. So EG and CG are perpendicular. And we know that EGT is 7x plus 2. So I'm going to put this right here. And I know that TGC is 4x. Now, I know that together, using the angle addition postulate, together they form a 90-degree angle because EG and CG are perpendicular. So I'm just going to say the measure of angle EGT plus the measure of angle TGC equals 90. Okay, I know that because the two lines are perpendicular and I'm using the angle addition postulate. Now I know that EGT is 7x plus 2, so I'm going to go ahead and substitute that in for a measure of angle EGT. And I know that TGC is 4x. So I'm going to go ahead and substitute that in. Now I can combine my like terms. And I get 11x plus 2 equals 90. And I'm going to solve for x. And now divide both sides by 11, and I get x is equal to 8. Now that's not the question. The question is find the measure of the angle. So if I know x is equal to 8, I can, using a calculator or using mental math, however you'd like to do it, TGC is 4 times 8, which is 32. And I know together they have to add up to 90, so I could multiply 7 times 8 and add 2, or I could subtract 32 from 90. Either way, I'm going to get 58 degrees. So the measure of angle EGT is equal to 58. Oops. Okay, let's look at our next example, and it says, first we're going to mark this diagram, and then we're going to determine whether each of the statements is true or false. So first of all, it says AG is perpendicular to CE. Just going to go ahead and outline that. So AG is perpendicular to CE. Let's mark that perpendicular. And then it says AC is perpendicular to BF. This one already is marked perpendicular, so I don't have to do anything extra. And then the last one, it says B is the midpoint of AC. So remember, that's how you mark a midpoint. Now, in this diagram, it doesn't look like it's the midpoint, but it is, okay, because it tells us that B is the midpoint of AC, even though it doesn't look like it is. Okay, sometimes these diagrams will be intentionally deceiving, just to make sure that you're using your theorems and not just guessing based on observation. Okay, it says angle 1 is congruent to angle CDG. Okay, so this is angle 1. We know that's 90 degrees. Angle CDG is also 90 degrees. So this first statement is true. So the second statement says GDF So let's find GBF plus FDE is equal to 90. That's true also because even though that's not marked 90, I know that two lines that are perpendicular form four 90-degree angles. Okay, so because I know CDG is 90 degrees, I know that all of the other angles are 90 degrees. Okay, then it says angle 2 and angle 3 are complementary. These are the two angles I'm talking about. That one is false. And then angle 2 and angle 6 are vertical angles. So here's angle 2, here's angle 6. Yes, those two are vertical angles. Therefore, we know that they're congruent. Okay, now the last step of this lesson is constructing a perpendicular line. The only way we can construct a perpendicular line is through this perpendicular bisectors theorem. And in order to discuss this theorem, we need to know what a bisector is. Okay, so we've been working with an angle bisector. An angle bisector cuts an angle into two congruent angles, but a segment bisector cuts a segment into two congruent segments. So just generally, a bisector cuts something into two congruent pieces. And a segment bisector cuts a segment into two congruent pieces. Okay, so here's an example of a segment bisector. So if this is my segment, and let's say that this is the midpoint, I'll call it segment A and B. Okay, so if M is the midpoint of AB, a segment bisector could be anything that goes through M. Okay, any of these could be segment bisectors. Now, the only way we can tell if something is a perpendicular bisector is if it's a bisector, but it's also perpendicular. Okay, so let's just define perpendicular. And this specifically will be talking about a segment. Okay, so a perpendicular bisector bisects a segment. So a perpendicular bisector, it bisects the segment and it's perpendicular to that segment. Okay, so now that we know this first piece, every point on a perpendicular bisector, okay, so now we know that what a perpendicular bisector is, we can move into the next part. And it says that every point on a perpendicular bisector is equidistant from the endpoints of the segment. Okay, so let's go back to this diagram that we had. Oops. Okay, and now this diagram, here's our segment A, B, where M is the midpoint. If we have a perpendicular bisector, meaning it goes through the midpoint and it's perpendicular to the segment, any point on this, like this point right here, is going to be the same distance away from A as it is from B. This point right here, same distance away from A as it is from B. Okay, and you could do that with any point here. It's the same distance away from A as it is from B. So let's use what we know now to construct a line that's perpendicular. In order to do this again, we have to just make sure that we first create a segment within our line. Okay, so the first step is to just draw a line. Here's our line. And draw some point on that line. It doesn't have to be in the middle. I'll draw T right here. Here's my line, L. Now, with our compass, the first thing we're going to do is create a segment. Because we can't bisect a line, we can only bisect a segment. So I'm going to use that point to make a segment such that point T is the midpoint of that segment. Okay, so here's point D, and here's point K. Here we go. Okay, now that I have a segment, now I can construct a perpendicular bisector. And my statement says that every point on a perpendicular bisector is equidistant from the endpoints. So I'm going to make my compass a little bit bigger. And I know that because I'm drawing a circle, an arc of a circle, that every point on this arc is the same distance away from K. Okay, K is my center. Every point on that arc is the same distance away from K. I also want it to be the same distance away from D, so I'm going to keep my radius the same, and I'm going to move over here and draw same arc from center D. Right, now my last step is to actually connect those 2 points, and I'm going to draw a line. Okay, in order to draw a line, you need 2 points. Okay, so those 2 points that I just constructed, point T, and the intersection of those 2 arcs, which are both equidistant from D and K, the endpoints of my segment, I can draw a line, and I know this line is perpendicular to line L. Okay, so you can find the step-by-step on your note sheet, but remember when you're doing constructions, you're only using your compass and a straight edge, no protractors, no rulers. So please jot down any notes or questions you have, and we can go through them next time I see you in class. Thank you.